two rows. Similarly, any two columns also you can do, but think of only rows. In the problems, you can do it on columns also. So if any two rows are interchanged, their positions. Say for example, R1 is interchanged with R3. The symbol for this is like this. When R1 is interchanged with R3, first row and third row are interchanged. The value of the determinant will not remain same. It will change, but it will change only in sign. So when determinant value is 7, for example, it becomes -7 when R1 and R3 are interchanged. So like that. So this is property 2. And property 3 is if any two rows are identical, if any two columns are identical, the value of the determinant is 0. We say that determinant vanishes, means its value will be 0. Something like A, B, C, -X, Y, Z, A, B, C. So the value of the determinant is 0. Directly you can write 0 because first row and third row are same. This is property 3. And property 4 is, if this is a very important property, if the elements of any row or column, leave columns, if the elements of any one row are multiples of, are multiplied by a number, the entire determinant is multiplied by that number. Means when you are multiplying a determinant, when you have to understand like this. When a determinant is multiplied by a number, you go in reverse order. When a determinant is multiplied by a number, not all the elements are multiplied by that number. Only one row or only one column is multiplied by that number. For example, I'll write one example. Say for example, 2 into determinant of A, B, C, X, Y, Z, 3, 0, 4. Yes. So what will be the next step? This is equal to what? This is equal to, you may say 2 into A, 2A, 2B, 2C, 2X, 2Y, 2Z, 2 3s are 6, 0, 8. So that is wrong. You have to multiply that 2 only to one row, either first row, second row, or third row. If you don't want row, you can multiply it to columns, but only one column. So now I will multiply it to second row. So second row becomes 2x, 2y, 2z. But first row will not become 2a. It is as it is ABC. This is 304. It will not change. So this is the property number 4. And what is the converse of this? So when you are multiplying a determinant by some number, you are multiplying only to one row. So what is the converse of this? The converse of this is when taking common. If some element is common, some number is common, it should not be common in all the elements. It is sufficient if it is common in only one row. Say for example, in this determinant, I can take 2 common from second row. First and third row, 2 need not be common. So while taking common, 2 as a common factor, 2 should be there only in one row or one column. It not necessary that it's present in all the rows. I'll give another example. You'll understand the converse of this. Say for example, I'll take 2 cross 2 determinant, AX, AY, C, D. So what is common here? So you may think that nothing is common in this determinant, because in matrix, when taking common, that A should be present in all the elements. Then only you can take A common. A can be taken outside of the matrix. So A alla element nagu irabekku. A. Avaga ನಾವು ಹೊರಗಡೆ ತಗೋತೀವಿ. But in determinant, it's not like that. Because already we have stated here, it is multiplied to only one row. So the converse of this is, if it is present common in only one row, you can take it out of the determinant. So now A is common here. So A is common means I can take A outside the determinant. So what I get? X, Y. Second row is not related to this as it is. Second row namgadu concern barange illa. So you can write as it is. Correct? So the converse of this property is, when you want to take some factor, some number as a common factor, it has to be common in one row or one column. So that is sufficient. So this is property 4. So property 5 is when the elements of one row are sum of two terms, then the determinant can be split as sum of two determinants. A1 plus x, B1 plus y. There are two terms. So the determinant itself can be split into two determinants. Now, if the elements of this row are sum of three terms, a1 plus x plus c, a1 plus x plus p, b1 plus y plus q, then this determinant can be split as sum of three determinants. Since there are two terms, a1 plus x, b1 plus y, the determinant is split into two determinants. If there are three terms, if each term of the first row here, if it is sum of three terms, then the determinant is split into sum of three determinants. Yes, what is the doubt? Somebody is asking the doubt. Please, yes, you can ask your doubts. You can write your doubts on the chat box. Yes. Yes, you can ask your doubts at the end of the classroom, or you can ask in the group. You can write your doubt and post it in the group. Okay. So if there are some three terms, if it is sum of three terms, then we get three determinants. First determinant plus second determinant plus third determinant. Property 6. The value of the determinant remains same by adding the same multiples of row. I've explained. When you multiply one row and add those multiples to another row, the value remains same. Say for example, if I write R1 changes to R1 plus 3R2, it means you should not multiply second row by 3 and write them in the second row. Second row will not change. You have to observe. You have to just multiply, write in one place or keep in your mind, and they are to be added to R1. So R1 should be changed, not R2. R2 is just multiplied and those answers are added to the corresponding elements of first row. So R1 is changed here, not R2. So this will change. Then property 7. Yes. From this actually we have to start today. If all the elements below are above the principal diagonal are 0, this is very important, particularly in CET. If all the elements below are above the principal diagonal are 0, then the value of the determinant is equal to product of the diagonal elements. So diagonal means principal diagonal. Such matrix is called as triangular matrix. I'll give one example also. Let me take another example. Determinant of 2, 0, 0, then 3, 4, 0, 1, minus 5, 6. So according to his statement, the elements on one side of the diagonal, below or above, now they are 0 here. The elements above the diagonal are 0. These are the diagonal elements, 2, 4, 6. This is called as principal diagonal. And what are the elements on the above side, on the right side? These are 0. Such matrix is called as triangular matrix. Okay. So this is a determinant of the triangular matrix. Similarly, 3, 1, minus 5. Here also the elements may be 0, either above the diagonal or below the diagonal, either to the left or to the right of the principal diagonal. If they are 0, then the value of the determinant is, it can be directly written 2 into 4 into 6. So what is 2 into 4 into 6? It's 48. You can verify it with an expandment notebook. Plus, minus, plus sign scheme togondo expand ಮಾಡಿ ನೋಡಬಹುದು. Definitely will get 48. So this answer you can write directly. So whenever the elements below are above the principal diagonal are 0, just multiply these diagonal elements. So answer is very easy, 48. 2 into 4 into 6. This is property number 7. And next, property 8. So last property. This is very simple. Everybody can understand. If all the elements of a row are 0, obviously the value of the determinant is 0. So nothing is there to explain. If all the elements are 0 in a row or in a column, definitely the value will become 0. You need not expand it, because where there are zeros, you take that row and expand, you'll get 0. So if all the elements in a row, or similarly if all the elements in a column are 0, the value of the determinant is also 0. This is property number 8. So this property you have to remember and apply them in the problems. We'll go to the problems. Shall we go to the problems? Is it clear? Properties. Okay, I'll explain property number 7 once again. Somebody is asking property number 7. If all the elements below are above the principal diagonal. So this is the principal diagonal. 2, 4, 6. This is called as principal diagonal. Above means these three elements. Below means these three elements. Either these three elements have to be 0 or these three elements have to be 0. In both the cases, it's called as triangular matrix. Upper triangular, lower triangular. So whenever either these three or both the sides may be 0. In such case, the value of the determinant is product of the diagonal elements. You have to multiply these three numbers. What are these numbers? 2 into 4 into 6. ಇಲ್ಲಿ ಯಾವ ನಂಬರ್ಸ್ ಇರ್ತಾವಲ್ಲ ಅದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿಬಿಟ್ರೆ we get the value of the determinant. ನೀವು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡುವಂತ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. You need not expand. Is it clear? I hope it is clear. Okay. We'll go to the problems. Repeat sixth. What is there in sixth property? The value of determinant remains same by adding the same multiples. Okay. I will write one determinant. Simple determinant I will take a, b, x, y. Okay. This is one more time I'm explaining. If I write r1 changes to r1 plus 5r2, what does it mean? You should not change r2. I'm multiplying by 5, but I'm not changing it. So what is 5 into r2? 5x, 5y. So they have to be added. They have to be added to which row? First row. So by doing so, what will change? Only first row will change, not second row. So first row plus 5 into second row. First row is a and b. So I will write a here. 5 into r2. 5 into x is 5x. So a plus 5x. And similarly, b plus 5y. b plus 5y. Here you cannot write 5x, 5y. That is wrong. Because I not written r2 changes to. ಇಲ್ಲಿ ಏನು ಬರೀತೀವಲ್ಲ ಅದು ಮಾತ್ರ ಚೇಂಜ್ ಆಗ್ತದೆ. ಆ ಕಡೆ ಬರೋದು ಏನು ಚೇಂಜ್ ಆಗಂಗಿಲ್ಲ. So r2 will not change. I have written r1 on the left side. Only that will change. So r1 plus 5r2 means a plus 5x, b plus 5y. ಇಲ್ಲಿ 5 into r2 ಅಂತ ನಾವು ಬರ್ದಿವಿ ಕರೆ, but ಅದು ಚೇಂಜ್ ಆಗಲ್ಲ. So that will be as it is, x1. Okay. This is property 6. This is actually very important property while doing the problems. Now we'll go to the problems. First question, the first main is like this. You have to observe without expanding. He has given in the examination. You have to observe whether it is without expanding or if it is not given. If without expanding, if that sentence, that phrase is not given, we can apply the property. After applying some property, after some steps, we can expand. Remember, listen to my words. Without expanding. If without expanding, if this phrase is given, then you have to apply only properties continuously for 2 steps, 3 steps, and finally you have to get the answer. You should not expand. Expanding means what? Expanding means taking this sign scheme, plus minus plus. This is called as expanding. That you should not do here. If it is, the question is like without expanding. If it is not given, just if it is proved that, then also you can apply the properties. But after some time, you can take this plus minus plus and expand. Without expanding and ಕೊಟ್ಟಿದ್ನಂದ್ರೆ ಈ ರೀತಿ ತಗೊಳ್ಳಿಕ್ಕೆ ಬರಂಗಿಲ್ಲ. ಡಿಟರ್ಮಿನೆಂಟ್ ಲಾಸ್ಟ್ ಗೆ ಕಂಟಿನ್ಯೂಸ್ ನಾವು ಪ್ರಾಪರ್ಟೀಸ್ ಮಾತ್ರ ಯೂಸ್ ಮಾಡಬೇಕು. ವಿದೌಟ್ ಎಕ್ಸ್ಪಾಂಡಿಂಗ್ ಅಂತ ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ ಸೊ ಒಂದ್ 2-3 ಸ್ಟೆಪ್ಸ್ ನಾವು ಅಪ್ಲೈ ಮಾಡಿ ಲಾಸ್ಟ್ ಗೆ ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್ ತಗೊಂಡು ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡಬಹುದು. But this question is without expanding. So how to do this? I will take LHS, left hand side. So what is the left hand side? X, A, x plus a, y, b, y plus b, z, c, z plus c. Correct? So this is the left hand side. So what is the RHS? 0. I have to get 0. Without expanding and so plus minus plus, so now delete that row, column, write the minor. No, that you should not do. So using only properties, 8 properties we have done. Using those 8 properties, you have to do this. See, when the determinant will become 0, you have to think. ನೀವು ಕೆಲವು ಜನ ಕೇಳ್ತೀರಿ ಸರ್ 8 ಪ್ರಾಪರ್ಟೀಸ್ ಒಳಗಡೆ ಇದೇ ಪ್ರಾಪರ್ಟಿ ಅಪ್ಲೈ ಮಾಡಬೇಕಂತ ಹೆಂಗೆ ಗೊತ್ತಾಗ್ತದೆ? How we should come to know that this particular property is used, has to be used, it has to be applied. So look at the right hand side, 0. So when the determinant will become 0, look at the all 8 properties. When 2 rows are identical, then the value of the determinant will be 0. So ಇಲ್ಲಿ ಯಾವ್ದಾದ್ರು rows identical ಅದನ್ನ ನೋಡ್ರಿ. First row ನೋಡ್ರಿ x a, second row ಯಾವ್ದು identical ಇಲ್ಲ. Columns identical ಅದನ್ನ ನೋಡ್ರಿ. Columns ಇದು first column ನೋಡ್ರಿ x y z, second column is a b c, So they are not same. But by applying the property, I can make some two rows or some two columns identical. So what I do is, you'll understand, C1 changes to C1 plus C2. Yes, what happens? C1 means this one, first column. Vertical arrangements are called as columns. Horizontal arrangements are called as rows. This is C1. This is C2. This is C3. C3 I marta illa. Only C1 and C2. C1 changes to C1 plus C2. So second column first column add ಮಾಡಬೇಕಾ? First column second column add ಮಾಡಬೇಕಾ? So ಇಲ್ಲಿ ಯಾವುದು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ನ ಯಾವುದು ಬರೀತೀರಿ ಇಲ್ಲಿ C1 ಅದಕ್ಕೆ ಆಡ್ ಮಾಡಬೇಕು. ಸೆಕೆಂಡ್ ನಾವು ಇಲ್ಲಿ ಬರೆದಿವಿ. ಇವೆರಡು ಸೇಮ್ ಇರಬೇಕು. ವಾಟ್ ಯು ರಿಟನ್ ಹಿಯರ್ ಅದನ್ನೇ ಇಲ್ಲಿ ಬರೀಬೇಕು. C1 plus C2. So add second column to the first column. To the first column means first column changes. Second column will not change. So C1 plus C2. Yes. ಇಲ್ಲಿ highlight ಮಾಡಿದ್ರೆ ನೋಡ್ರಿ, round ಮಾಡಿದ್ನಲ್ಲ. So ಇವೆರಡು add ಮಾಡಿದ್ರೆ, so what I get? Can you tell me? X plus A. Next Y, and this is B. Y plus B, because I written C1 plus C2. And last one is Z plus C. Correct? Is it clear or not? Write clear on the chat box. C1 plus C2. C1 is X, Y, Z. C2 is A, B, C. Right? I am adding C1 plus C2. Second column I am adding to the first column. So first column I have changed. I have written C1 here. Please. C1 already I have changed. Second column, third column as it is. Second column is A, B, C. Third column is as it is. X plus A, Y plus B, Z plus C. Now is it 0? Can you tell me, is it 0? Yes. I have written C1 changes to C1 plus C2. C1 means X, Y, Z. C2 means A, B, C. Just add them. ನೋಡಿ ಇದ್ರಾಗ ಏನು ಕನ್ಫ್ಯೂಷನ್ ಇಲ್ಲ. ಪ್ಲಸ್ ಅಂದ್ರೆ ಪ್ಲಸ್ ಮಾಡೋದು, ಮೈನಸ್ ಅಂದ್ರೆ ಮೈನಸ್ ಮಾಡೋದು. ಯಾವ್ದು ಪ್ಲಸ್ ಮಾಡ್ಬೇಕಿಲ್ಲ ರೌಂಡ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಇದನ್ನೇ ಸೊ ಎಕ್ಸ್ ಪ್ಲಸ್ ಎ, ವೈ ಪ್ಲಸ್ ಬಿ, ಜೆಡ್ ಪ್ಲಸ್ ಸಿ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ಯಾವ್ದಕ್ಕೆ ಆಡ್ ಮಾಡಿವಿ ಅಂದ್ರೆ, ಯಾವ್ದು ಚೇಂಜ್ ಮಾಡಿವಿ ಅಂದ್ರೆ ಓನ್ಲಿ C1 ಮಾತ್ರ ಚೇಂಜ್ ಮಾಡೀನಿ. ಇಲ್ಲಿ ಯಾವ್ದು ಬರ್ದಿ ನೋಡ್ರಿ, ಅದು ಬಿಟ್ಟು ಬೇರೆ ಚೇಂಜ್ ಮಾಡಬಾರ್ದು. ಸೊ C2 and C3 as it is. Now is it 0? Why it is 0? You can write on the chat box the reason. Which two columns are identical here? Which two columns are identical? ಯಾವ ಕಾಲಮ್ಸ್ ಸೇಮ್ ಕಾಣ್ತಾ ಹೇಳ್ರಿ. ಎಸ್, ಈ ಮಾರ್ಕ್ ಮಾಡ್ತಾ ನೋಡ್ರಿ. I have marked this one and here. Correct? Yes. First column and third column. C1 and C3. Yes, highlight ಮಾಡಿದ್ ನೋಡ್ರಿ ನಾನು. So by using that property number ನೋಡ್ರಿ, ಅದು 4 or 3 ನೋಡ್ರಿ. When two rows are same or two columns are same, directly you can write 0. ಮತ್ತೆ ಕೆಲವು ಜನ ಹೆಂಗ್ ಮಾಡ್ತೀರಿ, ಪ್ಲಸ್ ಮೈನಸ್ ಪ್ಲಸ್, ಟೇಕ್ ದ ಫಸ್ಟ್ ರೋ. No, that's not required. You have to apply the property. So according to that property, when two columns are same, when two rows are same, directly you can write the answer, that is 0. This is the RHS. So this is very simple and very interesting question. So this problem demonstrates how to apply the property. Look at the answer. What answer I have to get? Answer is 0. Answer 0 ಬರಬೇಕಾದ್ರೆ two rows have to be same, two columns have to be same. That you have to try. Adha now try ಮಾಡಬೇಕು. Okay, we'll go to next question. Problem number 2. This is also without expanding. Already we have written the main question. Prove that determinant A minus B, B minus C, C minus A, B minus C, C minus A, A minus B. Third row, C minus A, A minus B, B minus C. So once again, I will take the left hand side. Let me take the left hand side. Left hand side LHS. First row A minus B, B minus C. Put right. Take a notebook and pen. A minus B, B minus C, C minus A. Second row B minus C, C minus A, A minus B. Last row C minus A, A minus B, B minus C. This is the left hand side. Now answer has to be again 0. So ಯಾವಾಗ 0 ಆಗ್ತಂತ ಅಂತ ಹೇಳಿದ್ನ, when two rows are identical. ಬಟ್ ಇಲ್ಲಿ two rows identical ಇಲ್ಲ. Identical ಮಾಡ್ಲಿಕ್ಕೂ ಆಗಂಗಿಲ್ಲ. ಇಲ್ಲ ನೀವು ಮಾಡಿ ನೋಡಬಹುದು. C1 plus C2 ಮಾಡಿ ನೋಡ್ರಿ, ಸೇಮ್ ಆಗಂಗಿಲ್ಲ. Then how to do this? Identical ಮಾಡಬಹುದು, but yes, you can do. You can make two rows or two columns identical ಮಾಡಬಹುದು. But other than that, ಅದು ಬಿಟ್ಟು when the determinant will be 0, other than identical rows and columns, what is the another property? If you look at the last property, property number 8 I have explained. If all the elements are 0 in a row, the value will be 0 then also. So 2 rows have to be same, or 2 columns have to be same, or all the elements must be 0 in a row, not all the elements of the determinant in one row or one column. So that is easily applicable here. I'll write R1 changes to R1 plus R2 plus R3. Yes, somebody has written in the chat box C1 minus C3 R1 minus. Yes, ಮಾಡಬಹುದು. 2 rows become same. It is as good as the last question, last problem. But this is one more technique in this problem. R1 plus R2 plus R3. Add all the rows. First row plus second row plus third row. ಎಲ್ಲ add ಮಾಡಿಬಿಡ್ತೀನಿ. ಎಲ್ಲ ಯಾವುದಕ್ಕೆ add ಮಾಡಬೇಕು? You are adding to R1 means R1 will change. R2, R3 will not change. Okay. So ಯಾವ್ದಾದ್ರು one change ಆಗ್ತದಲ್ಲ. When I write R2 plus R3, R2 will change. First ಯಾವ start ಮಾಡ್ತದೆ ಅದು change ಆಗ್ತದೆ. ಈಗ ನಾನು R3 plus R1 ಅಂತ ಬರೆದ್ರೆ R1 change ಮಾಡಬಾರದು. R3 will change. So when I writing R1 plus R2 plus R3, R1 will change. So R1 changes too. So ಎಲ್ಲರೂ add ಮಾಡಿಬಿಡ್ರಿ. ನೋಡ್ರಿ A minus B. Observe, very easy. Very simple. A minus B plus B minus C plus C minus A. ಎಲ್ಲ ಪ್ಲಸ್ ಮಾಡಿದ್ರೆ ನೋಡಿ ಏನಾಗ್ತದೆ minus B plus B will be cancelled. Minus C plus C plus A minus A. What will be the answer? Answer is 0. Isn't it? Now similarly next R1 plus R2 plus R3. Next element minus C plus C minus A plus A. This is also 0. If you add here R1 plus R2 plus R3. If you add here then also minus A plus A. Everything will be cancelled. Only first row has changed. Second row 0 very well. Second row will be as it is. B minus A, C, B minus C, C minus A minus B. Then C minus A minus B, okay, B minus C. But according to property number 8, if all the elements are 0, 0, 0, 0 in a row, the value of the determinant is 0. This is RHS. We can do R1 minus R2, C3 minus C1. We can do. Then 2 columns will become similar, same, or 2 rows will become same, identical. Then also it will be 0. This is one more technique because by adding all of them, I get 0, 0, 0 in a row. This is easily, it can be easily identified here because A minus B, B minus C, C minus A. These are cyclic. When the expressions are cyclic, cyclic symmetry, we call it as cyclic symmetric expression. So when they are cyclic symmetric expressions, by adding them, we'll get 0 because they will cancel out. If it is minus, if it is A plus B, B plus C, then they will not be cancelled. A minus B, B minus C, C minus A. So they are cyclic, symmetric. So by adding them, they will be cancelled. So this is second problem. Is it clear? Please write clear. If it is clear, write clear. If there is doubt, you can type doubt and write your doubt in the group. I hope it's clear. It's very simple. Fine. Question number 3. Prove that determinant 2, 7, 65. This is very interesting. Let me see who will do this. Determinant 2, 7, 65, 3, 8, 75, 5, 9, 86. It has to be 0. I will not solve this. I will not solve this. So ಕೆಲವು ಜನ ಅನ್ಬೋದು ಸರ್ ನಾನು ಮಾಡ್ಬಿಡ್ತೀನಿ ಭಾಳ ಈಸಿ ಇದ್ರ ಏನು ಸರ್ ಇದು ಭಾಳ ಈಸಿ ಅದ I will do it like this ಅಂತ ಮಾಡ್ಬೋದು. LHS I will take first 2, 7, 65, 3, 8, 75, 2, 7, 65, 3, 8, 75, 5, 9, 86. You know, plus, minus, plus. No, without expanding. I have said without expanding. So without expanding, you have to prove that it is 0. Tell me what is the operation. Whether I have to change R1 or C1. Yes. Let us see. Very interesting. Let us see. Which column or which row I have to change? Just type it. If you want to change R1, write R1. Okay, somebody has written C3 minus 9. Yes, Naveen Hebbal. Very good. Naveen Hebbal has rightly identified. Very good, Naveen. C3 changes to C3 minus 9 C2. Exactly. Kumar, you have to change C3. Where is C3? This is C3. This is called as C3. Okay, the time is up now. We'll meet tomorrow. You do that operation. C3 changes to C3 minus 9 C2. We'll get the answer. We'll meet tomorrow at the same time. And please do this question. You'll get 2 columns the same. you get two columns the same. First and third column will be same. Then the answer will be 0. C3 changes to C3 minus 9C2. C1 and C3 become identical. So the value will be 0. No, till there is time. 10 minutes is there. I'm sorry. Let us continue. The meeting will end in 10 minutes. Still time is there. I'm sorry. Okay. 10 minutes they have given extra time for us. Thank you, Zoom. Okay, C3 changes to C3 minus 9C2. Let us do. So what I get? C3 minus 9C2. Yes, this is C3. This is C2. This column minus 9 into this column. This is 65. You can do some rough work in the margin. Rough work madona ಸ್ವಲ್ಪ 65 minus 9 into C2. Second column 11. This is second column 7, 8, 9. So 9 into C2 means 9 into 7. 9 7s are 63. Corresponding elements you have to add 65. Corresponding element is 7 here. 65 minus 9 into 7. 65 minus 63. What is the answer? 2. Correct. Next is 75. Corresponding element is 8. So 75 minus 8 Allah. 9 into C2. 9 into 8. 9 into 8 is 72. What is 75 minus 72? This is 3. Very good. And last number is 86. If you cannot do it in your mind, you can do some rough work. You can draw a margin and do some rough work. Rough work model. 86 minus, this is 9 into 9. 9 into 9 is 81. 86 minus 81. Fine. So which column I have changed? Observe, only C3. Only C3 means C1 and C2 as it is. C1 as it is. C2 also as it is. Now is it 0? Directly I can write 0. You need not expand. Plus minus plus sign scheme is not needed. Why it is 0? Reason, which columns are identical? Yes, first column 2, 3, 5. Third column 2, 3, 5. So this is 0. So very simple. So by doing the operation C3 minus 9C2, so you have to observe how I can make two columns identical, how I can make two rows identical. Sometimes I can do R1 plus R2, sometimes R1 minus R2. In the last question, R1 plus R2 plus R3. Here, C3 minus 9C2. You can ask me, sir, this 9 anta henge gottagtade? So very simple, common sense. These elements are very small, 2, 3, 5. Not elements just sannadu nodri adu. But ಇಲ್ಲಿ 65 ಅಲ್ಲ. So 65 ನೋಡ್ರಿ 2 ನೋಡ್ರಿ. If you compare, there is lot of, there is a difference. There is a large difference. So that means I have to subtract some big number from 65. So that's why it is 9 into 7. So if you observe these numbers, first column numbers, they are very small. These third column numbers are very large. So that's why I have to use some big number like 9, 8. Then only I can make them smaller. So 65 minus 9 into 7. So 65 minus 63. Then it becomes very small. So you have to observe carefully and make two columns identical. Next question is, prove that determinant 0a minus b minus a 0 minus c b c 0. Yes, its value is 0. In CET, please listen to me carefully. If this question comes in CET, you can directly write the answer as 0 because this is a skew symmetric determinant. It's a determinant corresponding to a skew symmetric matrix. You know what is a skew symmetric matrix? The principal diagonal elements are 0 here. The principal diagonal elements are 0 and remaining elements, the elements on left side and right side, the elements below the diagonal and above the diagonal, they are equal in magnitude and opposite in sign. This is C and this is minus C, right? C minus C, B minus B, A minus A. So these are equal in magnitude but opposite in sign. Below the diagonal and above the diagonal if you compare. And diagonal elements are 0. This is called as skew symmetric matrix. This is a determinant of a skew symmetric matrix. When there is a determinant of skew symmetric matrix of order 3, it will be, its value will be 0, not order 2. The order must be an odd number, order 3, order 5. So any odd order determinant of skew symmetric matrix will be 0. So directly you can write 0. So how we can prove it? This is very tricky. This is very tricky. What is the operation? Can anybody suggest? It's very interesting. Not so easy. Not so easy. By doing R1 plus R2, C1 plus C2, will not get the answer here. Like previous 3 problems, will not get identical rows. Let me see for some seconds who will answer. How will you do this? Yes. Okay. Here we'll use a different technique. You can try R1 minus C into R1. R1 minus R1 you cannot do. R1 minus some other row. R1 minus CR2 you can do. R1 minus CR1 is invalid operation. That we cannot do. That we cannot do. Okay, I will do like this. Just observe because time is less. It can be done in 2 steps. Naveen, yes. What are those 2 steps? Write the first step, Naveen. Tell me the first step operation. Which, okay, you write R1 changes R1 plus R3 like that. R1 plus 2 R3. What is the first operation you are doing? R1 changes to CR1. That is a wrong operation. R1 changes to CR1 means what? There is no meaning in that. R1 changes to CR1 means there is no meaning. I will do it like this. I will take the given determinant as I will take it as I will take some symbol. I will take delta. Let delta is equal to what is the given determinant? 0, A minus B minus A 0 minus C B C 0. Correct? I have taken the determinant. Sorry, I've taken the determinant value as delta. Now, according to the property 1, what is the property 1? If rows and columns are interchanged with each other, the value of the determinant remains the same. Same means equal. That's why I written equal sign. Okay. First property, you can interchange row with column, not row with row. If you interchange row with row, it will take a negative sign. It changes in sign. I'll interchange row with column. First row will be converted to first column. 0A minus B. I've written 0A minus B. Second row, I will make it second column minus A 0 minus C. Third row, what is the third row? B C 0. I will make it third column. Is it correct? Yes. First row I have converted to first column. Second row I have converted it to second column. Third row as third column. Then after this, what is common in the first row? I'll ask one interesting question. What is common in the first row? There's nothing common, but still then I will take minus common in the first row. According to the property, when you are multiplying the determinant by some number, it has to be multiplied to only one row. While taking common also, it has to be taken common from one row. In the first row, if I take minus common, what I get? Can you type on the chat box? If I take minus common from the first row, what will be the elements, new elements? Yes. Please, quick. If I take minus common, minus means actually minus 1 common. You should not write just minus. You can write yes. No, not 0 A B. 0 will be 0 only. Minus becomes this is plus A because I have taken minus common. Plus B becomes what? It becomes minus B because I have taken minus common. Yes, that's right. Similarly, take minus common. Again, minus 1 common in the second row. If I take minus 1 common in the second row, what do I get? I get yes, minus A 0 minus C. If I take minus common in the second row, I get minus A 0 minus C. Similarly, third row also I will take minus 1 common. If I take minus 1 common in the third row, this minus B will become plus B plus C plus 0. Is it correct? I have taken minus common in the first row, second row, third row. So what I get finally? Finally, I get minus into minus plus, plus into minus is minus. And what about this determinant? It is same as the given one. It is same as the given determinant. Is it determinant or not? 0 A minus B. Please compare in the to the determinant in the first step. 0 A minus B. Same. So what is the value of that given determinant? I have taken it as delta in the first step. Same delta I have got.